0. Then from here, remember what we have done earlier to sketch a curve. We know that since the value of A is negative, therefore this curve is a maximum curve. Alright? So from the graph, the maximum value of Q is the X value here. So the maximum point here, so the maximum value will be X equals to Q and Y equals to P, which is the turning point here. Okay? So to find the value of X, we use the formula negative B over 2A. Substitute B with 16 and A with negative 1 over 3, and then this will give us the answer 24. And therefore the quantity at the maximum point is equals to 24 units. Okay? So when Q is equal to 24, substitute this back into the revenue function. We have P equals to 16 minus 1 over 3Q. So P equals to 8. Therefore the price that will maximize the revenue will be equals to 8 ringgit. Okay? Next, the maximum value of R. So what is the value of R? So we have found the maximum value of P that make the revenue maximum is equals to 8 ringgit just now. So we use the value Y, right, representing the revenue. So substitute into the formula 4AC minus B squared over 4A. Alright, so A is negative 1 over 3 times 0 minus 16 squared. Alright, so from here, when you simplify, you will get 192. Therefore, we can say the maximum value of revenue is given by 192 ringgit. Okay? Example 5. Given the function of cost C equal to Q square minus 6Q plus 16, we have to find the quantity that minimizes the cost. Alright? What is the minimum cost? Second question. Okay, let's look at question A. How to find the quantity that minimizes the cost. So let's say Y is equal to X square minus 6X plus 16. So we compare with AX square plus BX plus C. We will get A equals to 1, B equals to negative 6, and C equals to 16. Remember, when A is a positive, this curve is a minimum. So this is what I have explained. So this is a minimum curve now. So the value of Q that minimizes the cost is given by X equals to negative B over 2A. So you substitute, you will get the answer equals to 3. Hence, the minimum cost is when Q equals to 3. So in order to find the minimum cost, we substitute Q equals to 3 into the cost function, which is Q square minus 6Q plus 16. So your answer will be equals to 7. Alright? Okay, next example. Example 6. The demand function is given as P square minus 100P plus 2500, and the supply function is given as 0.5P square minus 50. Find the price at equilibrium point. So remember, equilibrium is when the demand equals to supply, but we are told that the domain, the value of P must be in the region of 5 to 50. Next question, find the quantity for such price. Okay? So question A, at equilibrium point, the demand curve will intersect the supply curve, or we can say demand equals supply. So let's take the first function, P square minus 100P plus 2500, equation 1. And the second function is 0.5P square minus 50, equation 2. So demand at equilibrium point, demand equals to supply. So we will equate these two functions. So from here, when we simplify, we will get 5P square minus 1000P plus 25,500 equals 0. Compare this equation with AX square plus BX plus C. We will get A equals to 5, B equals to negative 1000, and C equals to 25,500. So using the formula which we have seen just now, the value of P is obtained by substituting the value of A, B, and C to the formula. So we will get the answer equals to 30 and 170. Right? So since the domain of P is given as between 5 and 50, so between these two answers we have to select P equals to 30. Okay? Next question, when P is equals to 30, so we have found the value of P equals to 30, so we substitute into either one of the two equations, so we will get Q equals to 0.5 P. Okay, so substitute with 30